Welcome to Algebra 1. Great to see you guys. Um, I hope this new format for Algebra 1 is helpful to you all at home as well as for me, that we're able to meet even if it's through a computer screen. I'm excited to be able to have just a little bit of algebra time with you all. So today we're looking at our Saxon. So your textbook should look like this. So we're looking at Saxon Algebra 1. This is our third edition. And we're going to look at 4 lessons together today, lesson 105 through lesson 108. Now, the great thing about this is we have time to explore these lessons, but also to kind of build on some of the past Saxon lessons that we've been doing. So let's jump right now into lesson 105, and we're looking at page 443. So if you would turn with me, that way we're working on this together and you can kind of see the practice problems and also the examples that your book gives you, because we'll be going through those. Now, we've talked about factoring. Factoring is one of those core essentials for algebra. It's actually one of the things that I love the most. And I know that a lot of my students tease me that I feel like if you come out of algebra, not at least not having a fundamental appreciation and understanding that factoring is going to follow you through a lot of your upper level math classes. So factoring is something that's so important. So we've been doing a lot with factoring. We've been looking into different quadratic equations and factoring those out and solving. Well, today we're actually doing a different type of factoring, and it's called factoring by grouping. And I know when you hear doing something different, our mind immediately starts to panic. But I actually think you're going to really enjoy this, because what we're doing is looking for something in common that we can take out and then solve by using what those factors are in common. So if you look on page 443 in your Saxon textbook, lesson 105, they remind you that if you're looking at multiple terms, what you have to do is take out what's in common in order to isolate those common variables and be able to solve. So your book gives you on page 443, xya minus 4a plus xyb minus 4b. And I know just looking at that, you think, oh my goodness, how could I solve that? There's so many unknowns. But your book shows you to take the first 2 terms and put those together in one group, and then the next 2 terms and put those together in a group. You know, we've talked before that steak is amazing, but how many of us would grab a huge steak and just try to cram it all in? That would be too much. So even things that we enjoy and that are good, we still need to take bite-sized pieces. So when we see these 4 terms, instead of looking at all 4 of those terms and thinking, I can't factor that, our book is showing you take down 2 factors, take down 2 factors, and then take out what's in common in those 2 factors. So it makes it more a bite size that we can enjoy, just like that good steak, right? So the book shows you by taking those first 2 factors, what's in common? Well, your book shows you the variable a. So they take out a. So if I take out the a, what's left? Well, it's xy minus 4. So I have my a, and then I have my grouping symbol. Now I go to the next part of my steak. I've cut it in half, right? And now I'm trying to take out what's in common in my second half. So I've got xyb minus 4b. Well, there's a b in both, so I can take out that b that's common to both. Well, your book shows you when you take out the a in the first part of your steak, take out the b in the first part of your steak, lo and behold, what's left is the same in both. So I can take out, because it's being multiplied to both of those, take out what's in common and then group together what's left. And it made a beautiful factoring problem just because I took out what's in common. I separated 4 terms into 2 terms each, took out what was in common in each, and then grouped together. So it made it a lot easier to solve. I actually think you'll like these a little bit better than you might even imagine. So turn with me to page 444, and we have 2 example problems, 2 practice problems that we're going to go through together, and I hope you'll like them as much as I do. All right, so page 444, and let's take a look at our first practice problem. So our first practice problem in the middle of page 444 is practice letter A. So we're on lesson 105, page 444, practice A. It says MBA minus 7A plus MBN minus 7N. And we look at that and go, oh, that is a lot to factor. We've been factoring quadratics. So when I look at this, I think that's 4 terms. How in the world? There's not an M in all 4 of these. There's not an A in all 4 of these. There's not an N in all 4 of these. So there's nothing in common that I can take out of all 4, but your book is showing you, let's separate the 2 and break them into parts. So how do I do that? MBA minus 7A is my first grouping, plus MBN minus 7N is my second grouping. I'm just breaking them apart into 2 different groups. Now let's just look at this first group. Is there anything in common? Anything I can take out? Well, I noticed that there's an A in both. So let's take out that A. What do I have left? Well, we know that in math, proper math, we should put it in the right order. So let's put it in the right order. BM minus 7, right? Because the B should come before A. It should have been ABM, correct? But I took out the A in common, so I'm left with BM minus 7. Now, so I've taken out what's in common in my first grouping. Now let's do it again. We've already broken it apart. Here's my second term. So let's take a look at this. So what's in common? N and N are the only 2 things I see. No numbers are in common, so I can only take out what is in common, plus N, and what's left? I'm going to put B first, then N minus 7. Now, if you'll notice, I've taken out what's in common in each, but look, friends, this part is left, and it's the same. That makes me really excited because it makes my next part much easier. Because since these 2 are in common and they're being multiplied by these, I'm just going to take out BM minus 7. And then I'm going to make a new grouping of what's left, A plus N. If A is being multiplied to this and N is being multiplied to this, that's just how foiling works, doesn't it? First, outer, inner, and last. A is being distributed to both, N is being distributed to both, so I can put A and N together in their own bracket. This statement is the same as this statement, and it goes all the way back to the first. So we've solved it, and all we had to do was separate it out, make it easier to work with, and now we've grouped it, and I factored it. I'm finished. Who would have thought starting out that factoring by grouping would be so easy? So let's do the second practice problem. And I would encourage you at home, push pause and see how you do on it, and then check it by going over it with me. All right? So let's take a look at practice B. And I hope you've paused it at home and taken time to practice it out. So practice B, what does that one look like? Do you think this one will be easier or harder than the last one? So let's look at B. NS plus 3NX plus 2CS plus 6CX. All right, let's remember the same format. I've got 4 terms here, and instead of allowing those to overwhelm me, I'm going to just break it into bite-sized pieces, 2 and 2. All right, so what's in common in these first 2? Last time I put it in a grouping, but I'm going to alleviate that step. I just wanted you to visualize it. So in this first step, I'm just taking out what's in common. The only thing I see in common is N. So I'm going to say N, S plus 3X. Now let's go to the next set of grouping. Plus, what would be in common in these 2? Now I notice both of these are even numbers, so I know 2 is in common. Do I see any other variables? C and C. So I'm going to take out 2C. Now I need to make sure that what I leave after I've taken out the 2C, it would be S plus 6 divided by 2 is 3. I took out the C's and I'm left with S plus 3X, right? All right, so I notice that these 2 do not work, do they? Because I've got N plus, and I've also got S plus 3X. So that's not going to work because they're not the same. So let's take a moment and go back to my terms. I've got ns plus 3nx plus 2cs plus 6cx. So if that won't work, then what I'm going to do is I'm going to erase, and we're going to go back up, because that means that they did not share anything in common, right? So instead, let's take my first and my third term, and let's see if I can isolate it that way. So ns plus 2cs, what would be in common with those two? Well, an s is in common. What does that leave me with? N plus 2c. So I took my first and my third term, and I'm going to put them in their own grouping. Because remember, the first time I did it, I used my first and my second, and it grouped together nicely. But I tried it in this one, and remember that if the grouping doesn't share anything in common, I can't factor by grouping. So I just went back. That's the great thing about math, is if I practice and it doesn't work, erase, go back and try again another way, right? So I did my first and my third term this time. So ns and 2cs, what was in common? What did it share? So it shared an s, so I took that out. ns divided by s would just be n. Remember that in your mind, you're always checking your work, so you can distribute that s back to both and make sure you get back to that first line. Now I'm looking at my second and my fourth term. So what's in common with those two? Well, there's a 3 in common for both. So plus 3, and n and x, c and x, the only thing they share is x. So if I take out a 3x, what does that leave me? N plus, now I took out a 3, so 6 divided by 3 is 2. I took out the x, so that leaves me with c. Now, do you notice anything? You see, the first time, I love using the first two, but when I did that, the grouping symbols did not match. So I knew I needed to regroup, right? That's a great way to word it. Regroup, retry again. All right. So now this time when I regrouped, I did get it correct, right? So what did I have? I have n plus 2c is what's in common. I take that grouping out. Since this is being distributed to both and this is being distributed to both, I combine the s plus 3x. So that's my final answer for practice letter B. So I did practice A as well as practice B. And that's lesson 105. So I hope that you tried that at home, and I hope that as you did it, that you understood that in this practice factoring by grouping, it's a great way for us to just try to find what's in common, and then do they share anything, and can I continue to factor that as well. So that was lesson 105, and that just shows us how we are practicing that factoring. I love factoring, and I think that's an important part of Algebra 1. Now let's take a look at lesson 106. So lesson 106 has a couple of concepts that we need to look at, and it's all about graphing. And we understand that linear equations, when we're graphing, are very, very important. So let's look on page 446 and lesson 106. So it talks about standard form. Now we understand that standard form is when we have our x and our y on the same side of an equal sign, and it can equal a number or a constant. So that is the standard form. Don't forget that when x and y are to the first degree, that's how I know it's linear, because x and y to the first degree is a straight line. And your book points that out. They give some examples of what standard form looks like. They say 4x plus y plus 1 equals 0. That's not standard form, because I need an x and a y equals a constant. So 4x plus y equals -1 would be standard form. All right. Now it also talked about, we call this our best friend in Algebra 1, don't we? We call y equals. All right, I apologize. The Wi-Fi ran a little bit slow there, so it started to mute us. So I hope you're following along still. All right, so y equals mx plus b is slope-intercept form. And we call that our best friend in algebra because it's important that we understand that y equals mx plus b. When I isolate the y, so if I take the standard form equation that we just had and I isolate the y, then what I'm saying is y equals my slope and then also my y-intercept, y equals mx plus b. So that's our slope-intercept form. I can take an equation that has been written in standard form and I can rewrite it in slope-intercept form so that I can easily find my slope and my y-intercept. Now, your book is talking to you about what if they give you 2 points and they ask you, come up with the equation of this line. Well, remember, I only need 2 points to make a line. So from those 2 points, what can I figure out? Well, I can actually take those 2 points, solve for my slope, and then also solve for my y-intercept, and then that will give me what my equation is. So your book is showing you examples there on page 446 and 447 about how to solve those and how you can plug those back in to find your equation. So let's take some time together to practice this through and understand how I can take 2 given points and solve for that. So when I'm given 2 points and they ask what is the equation of the line that passes through these points, understand that's all the information I need because 2 points are what are required to make a straight line, or in our case, what we're looking for, a linear equation. So let's practice together on page 448, and we're looking at these 2 points. So I'm excited to do that. I wish that I had a board that actually had the XY graph already up there for us, but I don't, so we'll have to somewhat make it, won't we? Now, I do want to encourage you that if you have graph paper at home, that might be a really great resource to use so that you can, you know, be able to visualize it even a little bit more. You don't need to graph it, you don't need to draw it out. We can actually algebraically solve this. All right, but they're telling me that my 2 points are 3, -5, and 2, -1. So instead of visualizing this first, what I'm going to do is actually just show you algebraically how we would do it, and then we can talk through what that would look like. All right, so if they gave me the 2 points, I really like to stack them because I think it's easier to visualize what you're doing. Do you remember how that we find slope? The measure of slope, M, is the rise over the run, right? We say slope is rise over run. We have to get out of bed first and then run. We often tease that it can't be run over rise because that would be a nightmare, wouldn't it? Because you would still be in bed and trying to run before you got up, right? That might be a bad dream. So slope is the measure of you've got to get up first, rise over run. Another way to look at that is the change in y over the change in x. So we're looking for how it goes up or down, and then run is left or right. So that's our slope. So how do I find slope? Well, the equation for slope to solve it is y2 minus y1 over x2 minus x1. Or another way is the delta symbol means change in y over change in x. They both mean the same thing. So if I'm looking at this is 0.1, this is 0.2, this is my x, this is my y, I like to stack it so that I can start at the bottom and just work my way up. So it's -1 minus -5. Or sometimes I just write a minus sign in between, -1 minus 5 over 2 minus 3. Do you see when they're stacked, it's easy for me to find that. I've had some students say, well, what if I make this 0.2 and this 0.1? That's fine. It doesn't really matter the order as long as you're consistent with both. I've had some students go this way and then this way, and that's not fair. Remember, in algebra, we always do the same. So if I started down here, I go up, start down here, go up. Or if you start at the top, go down, start at the top and go down. You can't switch the order once you've done one, do the same order for the next. So always y has to go on top, x has to go on bottom. Change in y over the change in x. So if this is a minus, So if I'm not going to the store, I am, right? A minus cancel each other out. So that becomes plus. So it'd be -1 plus 5 over 2 minus 3. So I end up with 4 over -1. So I had more, right? And then here I owed more. So I end up with 4 over -1. So therefore my slope is -4. That means it is going to fall 4 over 1, fall 4 over 1. So that's my steady slope is it's dropping, right? So we know that the equation of this line is going to fall because it's a negative slope. All right, now I know my slope. Now let's go back. We talked about standard form was ax plus by equals our constant c. So that's standard form, but today we're looking at y equals mx plus b. This is standard, this is slope-intercept. Well, remember I tease often that this is our very best friend in algebra, right? So if y equals mx plus b, I know y equals -4 is my slope, my m, so I'm plugging it in right here for my slope. So 4 equals -4x plus b. Well, my dilemma is I have 3 unknowns, x, y, and b. Now I know that my slope at any point in this line is down 4 over 1 because we figured out that was my slope. Well, in order to find what my y-intercept is, this statement will be true at any point on this line. So I can take either of these 2 points and use the x and the y for one of these points. In other words, I could use this first point or the second point, but I need to choose one and use that. In other words, I wouldn't use this x and this y because that point may not be on the line. Either point 1 or point 2 has been verified to be on this line, right? Because my equation gave me these 2 points and these 2 points alone. So use either point 1 or point 2. It doesn't matter which one, you'll still get the same answer. So in this case, I'm going to use point 1 just because it's first. At home, you could try and use point 2 and then come up and finalize your answer, and let's see if we get the same equation. So I'm using point 1. So point 1, the x would be 3. Be very careful because x is 3. Sometimes students plug it in first, but remember y comes first. Y equals mx plus b, but in our ordered pair, x comes first. So be careful you plug it in to the right spot. So x is 3, y is -5. So -5 equals -4 times 3 plus b. Now let's solve this. -5 equals -12 plus b. Now I've got one unknown, so I'm going to be able to solve what my b or my y-intercept. That's what in my equation y equals mx plus b. M is my slope, b is my y-intercept, and I need to know what is the y-intercept in this equation. So I'm going to solve to isolate b, so I'm going to add 12. So I'm adding 12, so b equals 7. So if b is 7, I have everything I need for an equation. I need my y-intercept and I need my slope. Y equals mx plus b, my best friend. So what does it look like? Y equals, slope was -4, x plus 7. So this is my equation. How did I get my equation? By using my 2 points. And I solved it for my slope and then used that slope and 1 point to solve down. Now, even if you use point 2, you're still going to get the same y-intercept because it will be true at that point as well. So I understand that if I were graphing this, 1, 2, 3, 4, 5, 6, 7, my y-intercept is 7, my slope is down 1, 2, 3, 4 over 1. Down 1, 2, 3, 4 over 1. So this is what the graph of this line looks like. It's falling. We read a slope from left to right, so it's falling, right? Just like a word, I read it from left to right, it's falling. So this is my equation. Now they gave me the point 3, -5, and that would be down further, 1, 2, and it would be right here, wouldn't it? So that's exactly what they gave us. And then they also gave us 2, -1, which is this. So these 2 points, but I also solved more points on the same. So there's just a way for you to visualize it. You actually don't need to do any of this at home. The only work you needed to do was the algebraic, the math part of it. But I wanted you to be able to visualize, how did I solve for that equation by just using those 2 points. All right, let's, I'd love for you at home to pause it and try practice B to see if you could get that on your own, and then unpause this video to see how we solved it. So I hope you'll take that time to do it on your own. All right, let's do practice B. This time I will not graph it because, again, I don't need it. I just did that just so you could visualize that with me. So practice B. Practice B, they gave me the points as -3, -3, and 6, and 5. All right, I put my 2 points, and now I'm going to solve for my slope. What is slope? Slope, we said before, was rise over run. It's y2 minus y1 over x2 minus x1. Now, you can label your points 1 and 2. You can label this as x and this is y. But it's very easy when they're stacked just to start at the bottom right corner and work your way up. 5 minus -3. Sometimes I'll even put a minus sign in between so I remember to do it in that order. Over 6 minus -3. You can put a minus sign here. Now watch your signs, because minus and minus is plus. If I'm not, then I am, right? They cancel each other out. So minus and minus means plus. Minus and minus means plus. Sometimes I'll even draw my line and join them together, right? Sometimes that makes it easier. So what does it end up being? 8 over 9. Oh, I always hope that they cancel out and work nicely. But in this case, my slope is going to be a fraction, isn't it? So 8/9. So go back to my best friend in algebra. Y equals mx plus b, my slope-intercept formula. So I know that my slope is 8/9. Now what can I do? I use either of these 2 points to solve. So in this case, again, I'm just going to use point 1. At home, you're welcome to use point 2, but they'll both solve out the same. In this case, x and y are both -3, so I don't have to be quite as cautious about which one goes where, but I do want you to remind you in other problems where the x and the y aren't the same, be on the lookout, because x is first here, but y is first in my equation, so be careful. All right, now I'm going to reduce this, because 3 divided by 3 is 1, 9 divided by 3 is 3. So I end up with -3 equals -8/3. Be very careful, because I had one negative right there. -8/3 plus b. I'm going to add 8/3. And that leaves me with b equals, oh, friends, a fraction, doesn't it? All right, so let's work this out. All right, so if I convert -3 whole into thirds, how many thirds would that be? Well, this is 3 over 1, so it would be -9/3, right? So I'm going to put a line through it. I'm going to put -9/3, because 9 over 3, -9 over 3 reduces to -3. So if I owe 9/3, but I have 8/3, what's left? -1/3. Well, that actually worked out a little nicer than we might have imagined, right? Especially since we knew we were working with fractions. So let's go back to our best friend. Y equals mx plus b. I solved for everything I needed. I solved for my slope. We found out what that slope was. It was 8/9. I need to put an m here so that way we don't forget that this was my slope and this was my b. So let's plug it in. M was 8/9. B was -1/3. Remember, I had more than I owed than I had, so that's why it's negative. So y equals 8/9 x minus 1/3. So I just simply in this lesson took 2 points, and those 2 points I used to solve for my slope, and then using that slope in either point I choose, A or B, or that calls it 1 and 2, either point I'm going to solve down to figure out what my y-intercept is, or my b. And that's very important that you know which one's which, your slope or your y-intercept. Both of those are extremely fundamental for Algebra 1. So I hope that that's a help to you as we look at lesson 106. All right, now let's turn. We're looking at lesson 107. So we've done 2 lessons. We have 2 lessons left to do. So as we look at this next lesson, we're still looking at graphing. And in lesson 107, we're still looking at the equation of a line and also even talking a little bit more about slope. So this is, again, fundamental to algebra. So I hope that, that as we study through this, that you'll make effort to understand that this is going to follow you into upper level math classes. So it's extremely crucial. Now, they talk to you about what if they give you a line and then they give you a point and ask you to find the equation of a line that is parallel to each other. Now let's talk a little bit about parallel lines. And if you look on your book on page 450, they show you the graph of 2 parallel lines. And I wish that I had a computer screen behind me that I could just pull that up on. But if you'll look in your book at home, it'll help you to understand what I'm talking about. When I have 2 parallel lines, what's really neat about it is think this through. Parallel lines, what makes them parallel is that they're equal distant at all points and they're parallel from each other. Well, an interesting fact about parallel lines is their slopes have to be the same. So in order for 2 lines to be truly parallel, their slopes have to be the same. Now, their y-intercepts will be different because they're going to cross the y-axis at different places, but their slopes will be the same. See, if I had one that had a positive slope, it was rising, and then one that was a negative slope, those aren't parallel, they cross each other, right? True parallel lines are equal distance from each other at all points. That's what makes them parallel. Therefore, their slopes are always the same. Now, that's going to be something that you're really going to use, not just in Algebra 1, but even in geometry. There'll be proofs later on that they'll maybe give you a given fact and say, these 2 lines are parallel. And immediately you'll say, oh, then if they're parallel, therefore their slopes are the same. And that's going to be a fact that you're going to use often in upper level math. Now, your book gives you an example that it gives you 1 point and then 1 equation. And you're going to look at that and say, wait a minute, last time they gave me 2 points and I could solve that. Well, you know, that's the fun part about math is I take what I know and then I apply to it so that I can apply something else and learn more based on what I've already attached knowledge to, and I'm growing on that. So if I'm looking at these 2, so they've given me 1 point and they've given me 1 equation. Well, what's great about this is it's going to actually be a little bit easier, because if they've given me the equation of a line and they tell me that this point is going to make a line that's parallel to the line they've already given me, I already know the slope because their slopes have to be the same. So I just use the first equation and I say, what's its slope? And then I can use the other point. So it's actually going to be less work than the problems in the previous lesson. And I like that. I bet you do too. Anytime there's a shortcut, we all like that, don't we? So I hope that's an encouragement to you that lesson 107 will actually be a little bit easier than lesson 106, just because there's 1 step they've already done for you. So I like that. All right. So let's take some time to do our practice problems, because there's actually several different practice problems on this lesson. So let's take some time to do it. We're on page 452. And there is actually letters A, B, C, and D. So we've got 4 parts to our practice problem that we're going to go through today so that you feel confident and ready to tackle the problems in lesson 107. So read with me. We're on page 452. So the first practice problem that it says is it gives us a point and it asks us to find the equation for a line that is parallel to this line. So let's take a look at the information given to us. So they gave us a point, and the point was -1, 2. again, this is practice A, right? So that's my point that they've given me. And then they told me that it is parallel to this equation or this line, right? Y equals -3x plus 1. Now, that's the great part about this lesson, is they've already given you an equation. So I'm coming in with the knowledge that I have one line and I need another equation of a line that would go through this point that's parallel to this one. So I'm looking at two lines that I want them to be parallel to each other. I already have one equation. I need to find an equation with this point. So if they've already given me this one, the great part that I know is that all parallel lines have to have the same slope, right? The same m, or I'm going to put in parentheses slope. Their slopes have to be the same. So when I look at this equation, help me. What number up there is my slope? Y equals mx plus b. What is slope? Slope is my m. So this would be my slope. When y is by itself, whatever coefficient is in front of my x is my slope, right? Plus 1 would be my y-intercept. They're parallel lines. Their y-intercepts aren't going to be the same. So I don't need to worry about plus 1. I'm not going to use plus 1 because these two lines with this one point and then this line over here, they're not going to have the same y-intercept, but they are going to have the same slope. So I use -3 and this point. So go back to my best friend. Y equals mx plus b. Well, I know their slopes have to be the same, so I'm just going to type in -3 there for m, right? So now I've got to plug in x and y. Please be careful. Y comes first, but it comes second at a point. So 2 is here, -1 is here, plus b. So now I'm going to solve it. 2 equals a negative times a negative makes a positive, so it'd be 3 plus b. Now I've got to get b isolated and by itself, so I'm going to subtract 3. So b equals -1. Now, what's my equation? They already gave me in my given what one equation was. They gave me the point that had to be parallel. It had to have a line that was parallel at that point to this line, so their slopes have to be the same. So what is it? Y equals mx plus b. My slope, we already said, if they're parallel lines, their slopes are the same. And I just solved, this one is -1. So y equals -3x minus 1. So we've solved it. Notice this one was +1. Would these two lines be parallel? Absolutely. How do I know for sure? Because their slopes are the same. And that's a fun fact for parallel lines. Now, let's look at the next one. It says it's given me another equation and a point and said that they are parallel to each other. The difference is they weren't as nice to us to put it in the right format. Take a look at it. And I'm going to erase my board, and I want you at home to think, what's the difference in practice A and practice B? What did they not give me that they gave me in practice A? I'm going to give you a moment to think about that while I erase this so I can get our board ready. All right, we did practice A, so now we're on practice B. I'm going to put a check mark through A because we completed it. Now, the point they gave me was -2, -3. So far, so good, and it looks similar to what we did before, right? So -2, -3 is my point. And it said again that it's parallel, same as what they did the last time. But did you notice the difference? 3x plus 2y equals 5. Did you notice it? Did you catch it? I hope so. So what was the difference? This time they didn't give it to me in my best friend formula, y equals mx plus b. My slope-intercept formula, right? They gave it to me in standard form. Well, standard form's great for finding my x and my y-intercept, but I need it in slope-intercept because I know parallel lines have the same slope. So what do? Well, I just get y by itself. So I'm going to take my standard form and I'm going to solve for y. So I'm going to subtract 3x. I end up with 2y equals negative 3x plus 5. Why did I not combine negative 3x and 5? I hope at home you're saying to your computer screen, because they're not the same, right? I can only combine like terms. So since they're not like terms, I can't combine negative 3x and 5. I'm still not done because I've got to isolate y. He has a coefficient with him. So I've got to get that variable by itself. So I divide everything by 2. Y equals negative 3/2 x. Don't forget the 2 gets to go to both, plus 5 over 2. Now, why did I need this equation to start with? Well, the only part of this equation I need to remember is that parallel lines have the same slope. So what is my slope? When I isolate y, it's the coefficient in front of the x. So in this case, I know my slope is negative 3/2. Parallel lines have the same slope, right? That's a key fact we want to make sure we don't forget. Parallel lines have the same slope. So I'm going to bring over my slope and my point. So this is one line, and I need another line equation that will be parallel to each other. So y equals mx plus b. My m we've already determined is negative 3/2, and since their slopes are the same, now I'm going to use my x and my y. Y is negative 3, x is negative 2, and I don't know what this y-intercept is. Remember, the y-intercepts will be different while their slopes are the same. So how do I solve this? Well, this would be negative 2 over 1, and the 2's would cancel out. Dividing both by 2 is 1. So I end up with a negative times a negative makes a positive. So I have negative 3, negative and a negative make positive 3 plus b. The 2's canceled out. So I'm left with positive 3. So be careful. In your mind, you might say, well, those cancel out. No, they're on opposite sides of the equal sign, so I have to do the inverse operation. So this side cancels when I subtract 3, but that would double. Negative 6 equals b. Be very careful that your 6's and b's stand apart so that you don't think they're the same. So negative 6 equals b. Let's rewrite using our best friend formula. Y equals mx plus b. My slopes are the same, so my slope is negative 3/2, and I know y equals negative 3/2 x minus 6. You see how I use that point, and it's x and y, and my slope in order to solve it down for my equation. Now I can figure out any point on this line, because remember, on every line, the slope and the y-intercept will be the same. That's my equation. I could find out when x is 0. If x is 0, y would be negative 6. I can find out any point on this line just based on this equation. So that's why the equations of lines are so important. All right, now there are still 2 more practice problems we want to go through on this lesson. Now it says the point 2, 3, and it has a slope. So they've actually gotten easier on our practice problems. They just gave us the point and the slope and said, hey, what's my equation? Well, friends, that's easy to solve for, isn't it? So if they just gave me a point and told me what my slope was, whew, we can easily do that using my slope-intercept formula, right? So we check off practice C, or practice B, and now we're on C. So they gave me the point was 2, 3, and they told me, hey, your slope is negative 2/5. Negative 2/5. All right, let me make sure. The fractions are so small that it's sometimes difficult to see. So I hope you're checking it at home. All right, so what's my best friend? Y equals mx plus b. That's slope-intercept formula, right? If my slope is negative 2/5, I'm plugging this in for x, this for y. Be careful because y comes first. 3 equals negative 2/5 times 2 is my x plus b. I'm solving for b. So what does that look like? Well, this is 2 over 1. They don't reduce, so it ends up being 3 equals negative 4/5 plus b. I combined by multiplying 2 times 2 is 4. I had one negative, so it's negative. Now I'm going to add 4/5. So I end up with b equals 3 plus 4/5. Now, I know typically when you were doing lower level math, we always kept things improper, but in algebra, we leave them improper, especially with slope, because you don't want to say a whole number and a fraction. So we usually just combine them. So I could multiply this into fifths, would be 3 whole times 5 would be 15 fifths. So if I add it together, it would be 19 fifths, right? So y equals, they already told me my slope was -2 fifths, x, and it's positive numbers, so it would be plus 19 fifths. All right, and that's my equation for practice C. Now practice D, one more just like it. They gave me the point and the slope. I would love for you to push pause at home. I'd love for you to take time to practice this to see if you get the same answer. So I hope you'll do that at home. All right, now let's take a look at D. Hopefully you paused it and took time to do it on your own. -3, 7, -3, and +7 is my point. That's my x, and that's my y. Remember, ordered pair, x always comes first. This one has a slope of 1/4, right? All right, so what's the equation of this line? All right, my slope-intercept, we nicknamed that our best friend in algebra, y equals mx plus b. So if my slope is 1/4, that's my m, y is 7, x is -3 plus b. So 7 equals -3/4 plus b. I'm going to add 3/4. Again, we just talked about fractions. So b would be 7 plus 3/4. You can leave it in that format, 7 and 3/4, or you can convert 7 over 1 equals what over 4? Well, that would be 7 times 4 is 28. So 28/4 plus 3/4, 28, 29, 30, 31 over 4. So I could say y equals 1/4 x plus 31/4. Or you could have left it 7 3/4. It means the same thing, right? Those are our 4 practice problems for lesson 107. So as we did that lesson, I hope that that's an encouragement to you that sometimes graphing may seem a little bit intimidating, but if you know your slope-intercept formula, hopefully that's a great place for you to start. So I hope that that will be a great encouragement to you. Well, we have one lesson left together, my friends, and this one is lesson 108, our final lesson for this week. So we're looking at square roots. If you've already continued in Saxon Algebra 1, then you know we've already looked at square roots previously. So what they're doing is they're kind of making it a little bit more difficult, square roots that we're looking at today. So one thing I want to point out to you that your book is really encouraging you to do is check. Always check to make sure, because sometimes in algebra, and especially upper algebra 2, you're going to get some problems, some solutions that you think are solutions, and actually when you plug it in, you'll find out that that is not a solution. So sometimes you might solve down and get 2 different solutions, and one of them is disqualified because when you check it, we call that erroneous, or you know that is not a valid solution. So that's why it's so important in algebra to check those. All right, so we understand that anytime we're solving for an unknown, we're isolating that variable and solving it. Well, in lesson 108, we're looking at square roots. How do I isolate that if it's under a square root? We'll treat that whole square root as something that needs to be isolated. Always in algebra, we're doing the inverse operation in order to solve it. So we're doing the inverse of square root. Well, just like the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of a square root is a square. We're raising that power, right? So let's take a look so we've actually just gone through, this is not a very long lesson. It's talking to you about how to isolate that radical symbol. That square root is another word, radical. So we're getting that by itself, we're isolating it. Always check your solutions, okay? So let's take a look at page 456, and we're looking at practice A and practice B for this final lesson. All right, so practice A. Lesson 108, practice A. Okay, so I've got the square root of x minus 6 minus 3 equals 0. Now, in our previous Saxon lessons with radicals, we just had the square root. So now we're actually having other things under here. So one thing I want to point out to you is think of this whole radical as your unknown that you've got to isolate to solve for your unknown. So if I want to get this by itself, the only part that's not under the radical symbol is minus 3. I'm undoing the order of operations, so I'm going to add 3, right? So I end up with square root of x minus 6 equals 3. Now, in order to isolate that, to get rid of the radical symbol, I have to do the inverse operation. So the inverse of square root is square. And I have to square both sides. So x minus 6 equals 3 squared is 9. Be careful, it is not 6. Sometimes we see that 3 and 2 and our brain knows to multiply. So instead of saying that, we need to remind our brain that it's 3 times itself 2 times, right? So 3 times 3 is 9. Now I've still got to isolate the variable, so I'm going to add 6. So x equals 15. I'm done, Miss Kim? No. Don't forget that I always need to verify. Is this true? You know, we live in a day and age where data and information can come at us. Always verify. Make sure, is that true? All right, so I'm going to verify. 15, I'm going to plug it back in. 15 minus 6 would be 9. The square root of 9 is 3. 3 minus 3 is 0. I verified, I put a check because I know that solution is true. And you would be very wise at home to make sure you do the same, because sometimes you may come across a solution that is not valid. So make sure you check that. All right, so we just did practice A. Let's try practice B. I'm going to put it right over here. Actually, I'm going to erase because I think we're going to run out of room on this one. It's a little bit different. So practice B is a little bit more difficult. Square root of, again, x minus 6. Same thing, only this time I've got minus 6 plus x equals 0. Again, remember that I'm trying to isolate this radical symbol so I can get rid of the square root by squaring. So how do I do that? Well, I move everything to the other side. So I would add 6, subtract x. Add 6, subtract x. So this would cancel out and comes to the other side. Can I join together 6 minus x and make it negative 6x? I hope at home you said absolutely not, because they're not like terms. So remember, when I'm adding and subtracting, if they're not like terms, they can't combine together. So I've got square root of x minus 6 equals 6 minus x. Now I've isolated the radical and I've got it set equal to something else. So how do I solve this? Well, I do the inverse operation, just like always. So that means I have to square both sides. So if I square this, this is x minus 6. The dilemma here is, unlike practice A, practice B, this is a binomial. So if I have a parentheses and I'm squaring what's inside of it, I'm really saying 6 minus x times 6 minus x. So what do I have to do? I have to FOIL it first, outer, inner, and last, right? So I take 6 and distribute to both. So let's rewrite this. X minus 6 equals 6 times 6 is 36. That's my first. Outer would be negative x times 6, so negative 6x. My inner would be negative x times 6, which would be negative 6x. And my last would be negative x times negative x would be positive x squared. So I've distributed each of these to all. That's where I get the acronym FOIL. First, outer, inner, and last, right? So now I've got to combine like terms to solve, right? I got rid of my radical, but I made a whole lot more, didn't I? Welcome to the last part of Algebra 1, because Saxon is really encouraging you to get ready for the next upper level. This is, in some textbooks, it might even be considered Algebra 2. So I'm really proud of you guys for where you're at. So how do I solve this? Well, I'm going to combine like terms, and I'm going to rewrite all of this in proper format. So first thing, I'm going to combine like terms, and I'm going to rewrite this. X squared should come first, minus 12x plus 36. Well, it equals this over here, but I'm going to bring it to the same side. So I'm going to add 6, subtract x. So what do I end up with? These two cancel, and I'm left with 0 equals x squared minus 13x plus 42. Now you may say, Miss Kim, we started out with a problem and I thought we were solving, and now we've got a whole different problem. Well, friends, I've gotten rid of the radical, but I've still got x squared and x. Do we know what to do with it? I know you absolutely do, because we've learned how to factor, right? So let's factor this. So I end up with x and x. Now, in order to factor, I know my leading coefficient has to be positive, which in this case it does. Nothing's in common. I can't reduce. So I've got to look at my last signs first. My last sign tells me that they're the same of minus. So I'm going to distribute a minus to both. Since they're both minus, they're going to add to make the middle terms. If they're both positive or both negative, when you add them together, they'll be the same, right? The same sign. So I know that they're the same of minus, so they're going to add to make 13. What factors of 42 add to make 13? Are you thinking? I hope they pop in your mind pretty quick. 6 and 7, right? 6 times 7 makes 42, and 6 plus 7 add to make 13. So I'm going to write 6 here, 7 here. It doesn't matter really which one I write first, because they're factors, and we know that our properties tell us you can change the order in multiplication and they're still equivalent, right? So I've got 6 and 7. If these are set equal to 0, I can break them apart. I can say, excuse me, I started to write my number first. I can say x minus 6 equals 0 and x minus 7 equals 0. I'm going to add 6 to both sides, and I end up with x equals 6. Add 7 to both sides, x equals 7. I'm done. I hope at home you said no, we still have to check. And I'm really proud if you remembered that, because we should always verify. Last step. Let's go back up and let's practice. 6 minus 6 would be 0. So then negative 6 plus 6 would still be 0. So this one worked out, didn't it? Now let's try 7. 7 minus 6 is 1. The square root of 1 is 1. And then I have 1 minus 6 plus 7 equals 0. So let's see how that works. So if I have negative 6 and I have 7, that's going to also leave me with 1. 1 plus 1 does not equal 0. So 7 was not a valid solution. So even though we worked it out and got 2 answers, when I checked, only 1 was correct. So my final answer for practice B is only 1 solution. So I hope that's a good reminder for you at home to make sure you verify. Some things you hear, you might say, well, I heard that on the internet. Well, it may not always be true, so always make sure you verify. All right, well, thanks for your hard work. Thanks for joining me, friends. And I hope that you're encouraged today as you're doing your Algebra 1 at home, that these truths that we're learning in Algebra 1 are going to be a great foundation for you into your upper levels. So I hope you have a great week and enjoy your algebra.